An earthquake is a continuous natural event. It is essential for humans to understand the causes and effects of earthquakes, because doing so makes buildings stronger and protects more people from harm. The basics of 2010 Chilean earthquake, its follow-up and steps that can be taken to minimize its effects on people will all be covered in this presentation. The crust, mantle, and core are the three primary layers that comprise the Earth. The movement of tectonic plates within the core of the planet releases stored energy within the crust in a movement, which is what causes earthquakes. Vibration movements are caused by the continuous movement, interaction, and collision of the Earth's crystal plates. The Chilean earthquake of 2010 was a massive and destructive event. The earthquake, which shook actively for 3 minutes, had a magnitude of 8.8. About 80% of the population got hurt or dead as a result, and the government had to spend a significant sum of the money rebuilding the nearby cities. The engineers discovered that population density was high enough to result in further accidents and death. The structures were extremely old, and the local inspectors were at blame for preventing their possible issues in sufficient time. This is a building we designed for Challenging 1, in which we also simulated an earthquake experiment. The junction between the second and third floors of our building were shaking and cracked, but the base was remarkably solid. Fortunately, our eggs made it all the way to the conclusion. This experiment taught me how to use the resources and time efficiently to make sure the structure is stable. The entire mountain was seriously impacted by the earthquake's intense surface shaking, which caused the rocks and soil to shift and slope to become unstable. This is because the earthquake's shear force is larger than its frictional force, which causes the mountains and rock and soil to become unstable and cause landslides. Landslides cause closed roads, residents harm or death, and damage to the soil, all of which have a significant negative influence on the infrastructure and neighboring communities. Humans can also suffer greatly from landslides, and the 2010 Chilean earthquake caused a tsunami that rose to a height of 2.74 meters. Chile in 2010 saw the decomposition of soil as well. An earthquake's shaking weakens groundwater saturated soil, resulting in a flood phenomenon that moves like a flood and significantly raises the possibility of landslides. We were also able to create the phenomenon and learn a way to lessen the impact of landslides on humans through experiment 2 in this Challenging 1. Naturally, we collected a wide range of data sets, and even with some inaccurate experimental data, we were still able to learn about the impacts of surface area, angle material, and the quality of material on the experiment. Land planning must include slope, soil qualities, and earthquake measures to lessen the effects of liquefaction and landslides. Moreover, materials that are closely packed together have higher direct friction and lessen the likelihood of landslides. Experiments have shown the mountains with a 30 degrees angle and higher massive are more stable. Making sure that there are few fatalities in future earthquakes is the responsibility of the civil engineer.